Hello guys, it's me Teacher Hanji and welcome to my channel. Our video tutorial for today is a little bit different with my previous videos since I will use the application DESMOS to show you the effects on changing the values of a, h, and k in the graphs of quadratic functions. A parabola has different transformation depends on the values of a, h, and k. It may opens upward or downward, narrows or widens, moves to the right or left, and moves upward or downward. Let us have this example. So I am here in the application DESMOS to illustrate different examples of graphs of a quadratic function. So let's say our graph is y is equal to x squared. So that is the graph of y is equal to x squared. I use y is equal to x squared because it is the simplest form of parabola. Its vertex pass through the origin 0, 0. And this function is also known as the parent graph. And we will use this parent graph h and k changes. So if you will notice, our parent graph here has a is equal to positive 1. So let's see if our parent graph is equal to negative x squared, in which the value of a is equal to negative 1, which is less than 0. See, the graph opens downward. Observe that if our a is positive, it opens upward, while if a is negative, it opens downward. Now, let us observe the graph of y is equal to ax squared. Let's see what will happen to our graph if the value of a change. Using our parent graph, y is equal to x squared. So that will be the graph. It passes through the origin. Let's say that the value of a here becomes positive 2. Therefore, our equation will be y is equal to 2x squared. Okay? So, from here, the value of a becomes positive 2. And that will be the graph. If you will notice, the graph of y is equal to 2x squared becomes narrower or closer to our y. So, let us have another example. What if our a is equal to 1/4, in which our function will be y is equal to 1/4 x squared. So, that will be the graph. If you notice, our graph y is equal to 1/4 x squared becomes wider. Let's compare this graph. If the value of a becomes negative, let's have our parent graph will be y is equal to negative x squared. So if you notice, it just mirrors our first parent graph in which the value of a is equal to positive. So since the value of a here is negative, then it opens downward. So let's say that the other graph will be y is equal to negative 2x squared. So see, it becomes narrower also, same as with y is equal to 2x squared. So only that this one opens upward while the other one opens downward since the value of a is negative. So let us observe if a is equal to negative 1/4. So we have y is equal to negative 1/4 x squared. So this will be the looks of its graph. So you see, whether it is positive 1/4 or negative 1/4, the graphs opens wider than the first two graphs. So why is that so? From this observation, we can conclude that when the absolute value of a is greater than 1, the parabola opens narrower. While when the absolute value of a is less than 1, then the parabola opens wider, especially if that is in fraction form and not greater than 1. So, if that is the case, then the graph of that function opens wider. Now, let's see the graph of y is equal to a times the square of x minus h. Let's observe what will happen to the graph if the value of h change. Again, I will be using our parent graph y is equal to x squared for us to easily observe what happens to our graph every time h changes. So for this parent graph, our h is equal to 0. What if our h is equal to -2? Then our functions will be y is equal to the square of x plus 2, in which h is equal to -2. So this will be the graph. Since our h is equal to -2, then it moves 2 units to the left of our parent graph. So let us have another one. What if our h is equal to -4? Then our functions will be y is equal to the square of x plus 4, in which h is equal to -4. So you see, the graph moves 4 units to the left of our parent graph. Now, what if our h is equal to +2? So let us see the difference. Our functions will be y is equal to the square of x minus 2. So this will be the graph. You see, this is the graph of y is equal to square of x minus 2. And it moves 2 units to the right of our parent graph. So the last one, what if our h is equal to +4? So our function will be y is equal to the square of x minus 4. Therefore, the graph here is equal to y is equal to the square of x minus 4. And you see, it moves 4 units to the right of our parent graph. Therefore, if there is a change of h in the graph of y is equal to a times square of x minus h, then if h is greater than 0, it moves to the right. But if h is less than 0, the parabola moves to the left of our parent graph. For the last one, let us observe the graph of y is equal to ax squared plus k. Using our parent graph, y is equal to x squared, let us observe the graph if the value of k change. So let's see if our k is equal to +2. Then we have y is equal to x squared plus 2, in which the value of k is equal to +2. So see what happens to our graph. Therefore, the graph y is equal to x squared plus 2 moves 2 units upward from our parent graph. So let us observe now if our k is equal to +4. Therefore, our functions will be y is equal to x squared plus 4, in which the value of k is equal to +4. So let's see. This is the graph of y is equal to x squared plus 4. So if you notice, these graphs move 4 units upward from our parent graph. What if our k is negative? So we have y is equal to x squared minus 2, in which the value of k is equal to -2. So this is the graph of that function. So if you notice, the graph moves 2 units downward from our parent graph. So how about if our k is equal to -4? Therefore, we have y is equal to x squared minus 4. So for the last one, observe that the graph y is equal to x squared minus 4 moves 4 units downward from our parent graph. So that is how the graph changes when k changes also. Therefore, from the function y is equal to ax squared plus k, if the value of k change, then when k is greater than 0, the parabola moves upward. But when k is less than 0, the parabola moves downward. So that's it for our video. Please keep in mind the following reminders on the effects on changing the values of a, h, and k in the graphs of quadratic functions. First, when a is greater than 0, the parabola opens upward. When a is less than 0, the parabola opens downward. If there is a change of a, the absolute value of a must be greater than 1. If that is the case, the parabola appears narrower. But when 0 is less than the absolute value of a and less than 1, the parabola appears wider. So that is the case when we have a is equal to a fraction which is less than 1. Now, if there is a change in h, then when our h is greater than 0, the parabola moves to the right. But when h is less than 0, the parabola moves to the left. Now, if there is a change in k, then when k is greater than 0, the parabola moves upward. But when k is less than 0, the parabola moves downward. So that's it for our video. You're doing a good job. Thank you for watching. See you again in my next video. Bye!